Alright, welcome back to another chemistry video of these chemistry topics that we talk about in our chemistry classes here at Badger High School. This is stoichiometry. It's one of the big ideas that we have for chemistry. It's something that if you don't know how else to solve a problem, just start doing stoich and you might get closer to the answer that you're looking for. So very important skill, and it allows us to predict how much chemical we might use or how much chemical we might make by using balanced chemical equations to come up with math relationships between two different substances in that balanced chemical equation. Now, I've focused on this word balanced chemical equation because we need to use those balancing numbers, the coefficients, in order to establish mole ratios, and those mole ratios are then used in our factor label problem, in our stoichiometry problem. So those mole ratios would come from coefficients like this 2, and then this imaginary 1, and then this 2. We can say that there's 2 copies of O for every 1 copy of CO2, and what that does is sets up a ratio for when we're comparing oxygen gas to carbon dioxide gas. For our class, we look at 3 different types of stoichiometry problems, and it's based on the units that we are provided in the text of the problem and the units that we're being asked to find in the text of the problem. So we have mass-to-mass problems, and when we have a mass-to-mass problem, we're going to use molar mass in grams off the periodic table 2 times. So that's a skill that you learned in your mole unit, which was either unit 3 for honors chem or unit 7 for, regular chem, and then unit 3 for chem fundamentals. The other problem would be mass to volume or a volume to mass. It just depends on where the mass is provided. Is it given to you, or is it being asked for you to solve for in the text of that problem? And we're going to use the molar mass in grams again off the periodic table, or there's a mole fact, 22.4 liters of gas at standard temperature and pressure. And for all of our math problems during this unit, we will be looking at standard temperature and pressure, so you can just say 22.4 liters of gas is equal to 1 mole. And then we have volume to volume problems as well, and that's where the text gives you a volume and you're being asked to solve for volume. So you use 22.4 liters 2 times in that problem. These problems are the same as the mole problems, we just add one additional step, and that one additional step is where we use that mole ratio from that balanced chemical equation. To start all these problems, we're trying to get to moles. So we're going to use molehill or a mole fact. 1 mole is equal to the molar mass in grams of a substance. 1 mole is equal to 22.4 liters of gas. We don't do problems like this, but you could also do 1 mole is equal to a number of particles. The second step is going to be to go from chemical A to chemical B, and we do that by using the mole ratio in our balanced chemical equation. We establish our ratio using those coefficients, and that's how we set up our fraction. So that gets us from chemical A to chemical B. This is the new step again. And then we go from moles to the unit that the question's asking for, if that's either liters or if that's either grams. And we use the mole fact again, molar mass in grams, or 22.4 liters to get us to that unit that's being question marked. So again, get to moles, mole ratio, sometimes I call that stack your moles, get to the unit in the problem. 3 steps, these will each have 3 vertical lines in our factor label grid. Here's an example factor label grid where we're going to, of course, start with what we know. Whenever we have moles stacked with something that's not moles, so either grams or liters right here, it's always going to be 1 in front of moles. And then the units will either be grams or liters, and we'd have 22.4 liters, or whatever substance that is, we'd look up the molar mass off the periodic table. Then we have our mole ratio step. We stack our moles over moles. Anytime we have moles over moles, we can have numbers that aren't 1, because these are going to be coefficients off of our balanced chemical equation. This is our mole ratio step that gets us from chemical A to chemical B. And then to finish up, the last step of your problem will be to get to the units that are in the text of the problem. In this step, you're going to use, again, 1 mole, because we have moles stacked with something that's not moles, either grams or liters, and this will either be 22.4 liters, or this will be the molar mass in grams off the periodic table. So after watching this video, you should have a pretty good understanding of the 3 steps of stoichiometry: get to moles, compare your moles, get to the unit in the problem, and how we're going to get to the mole ratio. We're going to use our coefficients off of a balanced chemical equation to establish that mole ratio. I hope that helps you work on these problems for this unit. Good luck.